Hello, everybody, and welcome to yet another interview with a prominent geologist, this time University of Washington geology professor Eric Cheney. Eric, where are you this afternoon?
I'm at my daughter Catherine's house in
Wonderful.
in Seattle, where the rain is.
The rain. Aha. Okay. Well, yeah, that sounds familiar. Thank you for your time this afternoon, Eric. Can you give us a quick bio? When did you start working at the University of Washington, and who was in the geology department back in those days?
Wow. Well, I got to Seattle in 1964. At
Okay.
that time, the chairman of the department was Howard Coombs, who was an engineering geologist and did a lot of work on the Columbia River basalt.
Okay, good. Um, and were you replacing somebody, or was a job created specifically for you and your expertise?
I was replacing somebody because he left abruptly to go to UBC. So
Okay,
the department had a problem. They had to find somebody to fill the position real quickly, and they found me.
okay. Well, you mentioned the Columbia River basalts. Can we start with that? I have been very interested recently in the idea that those Columbia River basalts, once upon a time, when they erupted, crossed partially or completely a Cascade Range that was much lower than it is today. I know that you've done some thinking about that. Bates McKee was doing some thinking about that. And before him, J. Hoover Mackin. Do you think the idea originated with Mackin? And did you know Mackin at all?
I knew Mackin, but I don't believe I copped any ideas from him on the basalt.
Okay. Well, it's a tantalizing idea, even though there's hardly any basalt left in the Cascades, like a couple little scraps, and maybe that's it. Uh, I picked up on the idea, I think, from hearing you and also Bates McKee. Tell us about Bates McKee. I'm very interested in that gentleman and his beautiful textbook. That's about all I know about the guy. Could you fill in some detail on Bates McKee, please?
Okay, so Bates was my age, and he was very interested in the geology of Washington, and
Hmm.
he was an expert communicator. So he fascinated a lot of people. Uh, Anything Bates said at the time uh, has been significantly modified since then. And that's true of virtually everything anybody said at the time. I mean, there's been a lot of blood under the bridge
Okay, okay.
since the 1960s.
Sure, sure. And were you, so thinking specifically about those basalts, um, when do you like the rapid uplift of the Cascades? Were you publishing? I mean, I've been using it. I don't know if you can see this, Eric, but I've got your
I can
beautiful
see it.
textbook here. Yeah, I mean, this is
Yeah.
a fantastic piece of of collection of papers. Um, what's been your latest thinking about when the initiation of the rapid uplift of the Cascades took place? It must have been after those CRBs, right?
Oh,
Everybody agrees with
absolutely.
that. Yeah.
It's all since 4.2 million years. Uh, the oldest unit, which is uplifted, is the basalts and other volcanic rocks in the southern Cascades in the area of shucks. What's the name of those
Mhm.
rocks? Anyhow,
Yeah, yeah. In the South Cascade. So you've got some lava flows that have been dated at 4.2, and those have been jacked up to high elevations.
they
That's the
have.
yeah. Um,
Those are
I
called
mean,
goat rocks.
goat rocks.
Yeah.
Okay. I guess I haven't heard that before. That the goat rocks lavas help us with the Cascade Uplift story. I know this is
Yeah, because
unscripted. Go ahead. Yeah.
they've been dated at 4.2,
Okay.
and the base of those rocks is a thick basalt, which is mostly clastic. That is, it's fragmental, laid down, basalt debris laid down by water.
Okay.
For example, the city of Portland is built on that stuff.
I see. Okay. Um, so this is not goat rocks up by White Pass. This must be some different goat lavas.
Well, it's pretty close to White Pass. You're in
Okay,
the right
okay,
ballpark, yeah.
okay. Um, so the idea, if we want to think about an uplift of the Cascades, and your number is 4.2, is tied to finding some lavas that were erupted at lower elevations and then having them higher today.
Right.
And yeah, so does it feel like there's debate? Like, seems like everybody I talk to, they like the initiation of the Cascade Uplift at 7 or maybe as old as 10, using all sorts of different evidence in the rain shadow.
Well, I
Uh,
would say 10 years ago, people would say the Cascades came up 30, 40 million years ago. I'm glad to see they're edging towards 4.
well, that's an interesting statement. So why the change? 10 years ago, what was the argument to go back that? I mean, were they literally saying uplift before the CRBs? 15, 20 years ago?
Yeah, 10, 15 years ago, the concept is that the Cascades have been there forever.
Huh, huh.
Uh, what's Dad, I've heard in geology that lots of rocks have moved great distances and on faults. We're just coming to appreciate that for rocks younger than 40 million.
Hmm.
That's well established now for rocks that are between 100 and million and 50 million, but it's only coming into focus for most people
Yeah.
that this is much younger, continues to be much younger.
Did you, in your publishing such young dates for this activity, meet resistance?
I'm sure it was an unpopular idea, but
Well,
all new
that's
ideas meet resistance, right?
yes, exactly. Well, just to let you know, I've been talking to some USGS folks in the last couple of weeks, and Jim O'Connor and Lydia Steisch. I don't know if you know those names, but they're talking about a 3 million year rapid uplift in the Cascades.
Well, I
Use,
won't debate that.
yeah,
I think I said since 4 million. So
exactly. Yeah,
a fair
right.
amount of it was younger than that. And you
Yeah.
can show that some of it is younger than 1.5 million.
Hmm. And just off the top of your head, uh, are those more lava flows that are like younger than 2 million years that show this uplift? Or what kind of data sets are you thinking about to support that very, very young uplift history?
Uh, that's a good question.
This is just off the top of our heads now,
Yeah,
you
well, you
don't,
got to get me
yeah.
to put the top on my head.
Well,
Uh, there's a lava flow that goes down the west side of, down the east side of the Goat Rocks.
okay.
And that lava flow is younger than 1.5 million. And some of the 1.5 million rocks are tilted
Mhm.
to the west, tilted to the east,
Tilted
which
to the
shows that
east.
they have been uplifted on
Yeah.
the west.
That's the Titan andesite lava you're talking about?
Uh, they're pretty well, andesite, basalt, same
Yeah.
family.
Right. Coming from the Goat Rocks and that major flow coming down the Tieton River. Yeah, I think I'm
That's
familiar.
it. Tie it and flow.
Yes, good.
Very
Um,
good.
and just the base of that Tieton flow is tilted, it appears, as opposed to being just
Well, the whole flow is tilted.
the whole flow. Yeah. Okay. Um, so that
And
comes to mind. Please
it
go ahead.
continues to be tilted. I mean, it's still going on.
Well, that's okay. Now you got me thinking, Eric. So aren't there kind of two questions? One is when do we initiate rapid uplift of the Cascades? And two, why? Why do we have a sudden uplift, or maybe it's not sudden, but why do we accelerate the uplift of the Cascades? I don't know the answer to that. Is something going on offshore with the
Yeah, you got it right. The subduction zone offshore
okay?
started about 1.5 million years ago. and it's
Okay.
impinging on the continent
Hmm.
and causing the continent to rise.
I see. I see. Um, well, let's shift towards your you've been publishing on this for many years, the idea of these regional unconformities that can be traced across the Pacific Northwest, and not just local basins, but you can have a major story, which I love. I love that idea of telling a more broad story. Can you give us a sense of what got you thinking about regional unconformities in the Northwest, and what the power is of thinking that way?
Yeah. When I arrived at UW, there was a professor by the name of Harry Wheeler.
Hmm.
And Harry was one of the early proponents of extensive unconformity bounded sequences. So I think I got infected by Harry.
And before your work, people just weren't thinking about those regional
Now, up
unconformities?
to before my time, everybody thought these were local basins and local mountains. The whole idea that that they're not basins,
Yeah.
local basins. They're sheets of sediments and flows that went across what is now the state of Washington, and
Hmm.
that's an entirely different concept than thinking of local basins.
Yes. Yes. And so back to the flood basalts, which are flowing basically on top of one of those unconformities, I think, right? The idea is
That's
before the
fair.
flood basalts, were there, a few million years of missing time before we unleashed the Grand Ronde lavas? Am I thinking of that correctly?
Uh, I think the basalts rest on various volcanic rocks of the southern Cascades. And
Okay.
there's not much of a time lapse between them, maybe just a million or 2 years at most, which
Okay. Okay.
geologically is a blink.
Yeah. But it is one of your unconformities, I think, right
It
there
is.
at Grand Ronde time. Yeah. Um, and I think I want to come back to these lava flows crossing the Cascades. I just did a program on it, and everyone was excited watching the program, like I'd never heard of this before, never even thought about the idea that these Grand Ronde lavas made it any further west than, Cle Elum, Washington, or Rimrock Lake or something like that. Has there been resistance to that idea just because those CRBs are not up in the high Cascades?
Oh,
Or
there
no?
probably is. I think that resistance is melting. It's becoming increasingly obvious, I think, to most people. Now, first of all, I want to correct you.
Yeah.
The basalts did not cross the Cascades. The Cascades were not there when the basalts came out. So it was essentially a flat plain. And that's why the basalts could get all the way to the sea. There was no great topographic or other barrier to intercept them.
Well, I've been doing a series of video programs this winter, and we've been marching through time with the history of the Cascades going back 60 million years. And what you just said is the thing that we just kind of all decided together, like, wow, we still don't have much of a mountain range 30 million years ago, 20 million years ago. And to visualize a plain or even just a few little stumps of things that Paul Hammond maps or something like that, that's the concept, right? So
It is.
it's easier to get to I-5 if you don't have a big mountain range to cross.
Absolutely.
Yeah. Um, are you familiar? Do you remember anybody talking about Steamboat Mountain between Mount Adams and Mount St. Helens, which apparently is a remnant of some Grand Ronde lava that's now kind of stranded up in the mountains?
I'm not familiar with that, but it doesn't
Okay.
surprise me if somebody has
Yeah.
done that.
Yeah, there's that and Squaw Mountain or something like that nearby. So, to my knowledge, those are the only two kind of remnants that are obvious of what was once potentially an entire cover of those CRBs. And I did get a hold of Don Swanson and ask him when he was doing his mapping on the east flanks of the Cascades in the 60s. What do you think about this idea? And Don Swanson's like, yeah, I was looking like crazy. I was on the lookout all through the high Cascades for my whole career to find some of those CRBs. He said, I never did find anything, but I'm not opposed to the idea of those flows making it across, which begs
Well,
the
I
question.
remember him
Yeah,
saying that.
yeah. Which begs the question, has anybody found any hint of CRBs in the Puget Lowland,
Of
even in the
course.
subsurface? They
Yes, of
have?
course. Uh, so there is CRB in the Puget Lowland, but it's in the southern part of the state where we don't take much notice. Okay. There are some CRBs between the lowland and the Pacific Ocean, which is perhaps even more tantalizing for you.
Yeah.
Um, for example, the Olympic Mountains are made up of remnants of CRBs. That's pretty far west, right?
That's pretty far west, and I'm certainly aware there's basalts out there, but aren't those basalts from like Silesia time?
Some of them are younger than that. I'm sure there's Silesian stuff.
Yeah. Huh. Okay. Well, that's worth looking into. And yeah, those CRBs that are down by Centralia and Chehalis, little knobs here and there. I
Yep.
think most everybody is aware of those, but they're assuming that they came through the Columbia Gorge, right? They came through the lowland and basically flowed north.
Yeah, a lot of people think they came down the Columbia Gorge, then turned and flowed up the rivers to the north, and then flowed west down the rivers to the sea.
Yeah,
Much easier to imagine that there were no topographic barriers at the time.
I agree. I agree. Yeah, that's fun. That's really fun. Um, I think I would love to share this book with everybody who watches these programs, but I don't think I can find a digital copy. Is that true? Are there just the hard copies that are
I don't
available?
know where there's a digital copy.
Okay. Well,
I
I'll
can't
keep
help you
looking.
there.
Yeah. What's the history of this book, Eric? Was this a labor of love for many years to try to put this
Yeah,
together?
there's an introductory chapter that says that this was the result of a symposium in 2002,
Yeah.
and I was the one who organized that symposium. And it took a long time for it to come to fruition. Whenever you have a bunch of authors, you're at the mercy of the slowest of the bunch.
Yeah.
So it took a while.
And did you feel that there was a need for that book, that you felt like there wasn't a broad Geology of Washington publication that had some
I
modern
would say there's not
ideas?
such a thing today, unless you know of one that's been published in the last year or two. There's still not something that does the geology of Washington in a modern way.
Well, yeah, I agree with you. And yeah, there is a role for interesting books. I mean, I think you know that there's a lot of appetite for geology. People love this stuff, and from all walks of life, I think, as well. Did you do a combination of teaching and research, or,
I
or
did
did you? And were you out in the field with students a fair amount?
quite a lot.
Where
My
did?
original interest was ore deposits, especially in Washington. And then from there, I got into the geology of Washington, which, of course, the
Mhm.
ore deposits are a part.
Yeah.
And from there, I got into this concept of unconformity bounded sequences.
Well, if I can get this book to people's hands, that's a major part. You've got more than one vignette talking about and chapter talking about those unconformity sequences, and I need to do more with those because there is some really nice stories coming out of that work, and I do appreciate that work that you've done. Um, who do you remember collaborating with across the state? I remember you dealing with Andy Buddington a fair amount at
Yeah,
Spokane Spokane
Andy and
Community
I
College.
worked mostly in the Okanagan Highlands, not on the
Okay.
basalts.
Yeah.
There's
Yeah.
some interesting stories there.
Yes. Well, good. So, anything you'd like to add here about the uplift in the Cascades? If I can come back to that one more time, Eric, it feels like it's a major story that doesn't have a lot of work done on it. Like, what's driving the uplift? Where are the structures that are bounding this uplifting mountain range? Is it not a structural story? Is it some sort of
It is a
magmatic?
story.
Okay.
If you turn to
Yeah.
this book,
Sure.
some colored
You know what?
figures early on in that book.
I'm going to share my screen here, Eric, and we'll just look at this together with you narrating. That
Okay.
would be wonderful. I don't know how well you can see this, but I've got the book right here. So let's go to some colored plates. Yeah. So which page should I turn to here?
That's a good question. Can you read some of this stuff, Kay? What's this? We want to go to this figure here.
Plate
Okay.
15.2.
15.2.
15.2 coming right up.
There, that's it.
Yes. Okay.
Now you can see various heavy lines on that, and those are folds that go across the state.
Yep.
And more importantly, what I really want to stress and what your viewers need to know, the Cascades are a giant anticline. An anticline is a fold that closes upward.
Okay.
Viewers familiar with that?
We are, yes.
Okay. So this anticline goes from, wow, can hardly see my own stuff.
Sure.
It goes do you see this this is a good indication right here near Goat Rocks.
Oh, good. Yes. Yes.
Okay, so you can see in the middle of that, what's that?
NW.
Anyhow, this anticline
Yep.
goes across the state approximately like that. And so in general, rocks to the east of that dip to the east, and rocks to the west of it dip to the west.
I see. Yeah, let me share that map with the viewers as well. I've got one here on the document camera. And so we're talking about the Goat Rocks right in here. And so this is the Goat Rocks, which sounds like it's a pretty important place for you, Eric, with some of the thinking you've been doing. Those Goat Rocks. Yeah.
See, the youngest rocks in any place are the first ones to be eroded because they're closest to the surface.
Yes.
So in geology, the youngest rocks are the most thoroughly eroded. So it's only where you have remnants of young rocks that you can see the young structures.
All right.
Were you able to draw this? Are you able to see that?
Yep, we got it now. Oh, I see. Oh, yeah, let's do it again there, Catherine. Thank you. Oh, so that's the trend. That's the crest of your anticline. I see. Yes. Okay, good. And so you're thinking we need to begin that uplift 4.2 million years ago, and do you think of it as a rather dramatic acceleration? Like it's some flip of a switch and we had hardly any uplift and then we just have a lot?
No, because there are other unconformities below this which record former uplifts and erosion. So it's been happening in the Northwest for hundreds of millions of years.
Yes.
And it's probably because we're on the leading edge of the North American plate and the Pacific Ocean keeps trying to collide with us.
So you've got an unconformity at 4 and one below that at 20, I believe. And so
Well,
should we visualize an uplift 20 million years ago then as well to have
sure, you
a
can
kind of a
visualize that.
yeah, okay.
Let me say a few things before this, before we expire in time.
Yes.
Are your viewers familiar with the concept of flood basalts?
Yeah, I think we are.
Okay. The Columbia River is the smallest flood basalt on the planet.
Mm-hmm. Yeah.
And that's because we have not explored in the subsurface the extent of the basalts. There are basalts in British Columbia and elsewhere that probably are part of the Columbia River basalt story.
Whoa.
They may have slightly different compositions and slightly different ages, but they're all probably part of the same story. So in that sense, the Columbia River basalts probably covered much of the Northwest. So
Well,
Columbia River basalts that you see today are the smallest flood basalt on the planet. And that should give us reason to pause and think that they could have been much larger.
well, I do like crossing the border mentally up into Canada and making some connections, but I had not made that connection before with those flood basalts in BC compared to the flood basalts we have down here. And it's ignorance on my part. I don't even know the most basic things about the age of that system. And do they have their own fissures or potentially they're,
Well,
I mean,
you are the victim of looking at modern day topography.
right,
I
right.
mean, of course you do. That's what all the maps show.
Yeah,
But
yeah.
when the basalts came out and when the older rocks came out, the topography was different.
It was. Eric Cheney, are you saying that some of the Grand Ronde flows potentially flowed across the border to the north?
I'm not sure I can say that, but they certainly flowed to the sea.
Certainly flowed to the sea. And so you're visualizing the Olympic mountains also being quite low at the time.
Yes.
Okay.
And
Well,
yeah, go ahead.
that's I think to follow that set of ideas, if I'm serious about following the idea, then yeah, we talk to as many people as we can who've done mapping on the Olympic Peninsula and see, are we sure all those basalts are Silesia? And if they're not, where are these basalts that are maybe not Silesia and maybe are Miocene?
Okay. If you look at this map here,
Yep.
you'll see the Olympic Peninsula, the outcrop pattern is kind of horseshoe shaped.
Yeah.
Well,
Yeah,
that's another anticline that intersects with the Cascade Range anticline. So I'll just, freehand this in.
Good. While you do that, I'll show the viewers in my copy, and we'll get to your drawing in a second. Okay, so viewers, Eric is talking about the patterns here in the Cascades.
Here,
yeah.
This is the Cascade Range anticline here.
Mm-hmm.
So what I like to refer to this as an egg crate. You know what an egg crate looks like? It's got intersecting folds, and the eggs are in the depressions between the folds.
Mm-hmm.
And you can think of the ribs of an egg crate as being anticlines in Washington. So it's an egg crate, and the age of the egg crate is younger than 4.
Younger than 4. No egg crate before 4.
There could have been all sorts of structures before then.
Yes.
And they have been eroded or covered, so we are unable to describe them in the specificity that we can describe the basalts.
But another way of thinking about it is we start the most recent egg crate, 4.2, and we're still working on the egg crate The egg crate is the cups are still getting deeper and the ridges are still getting
course,
higher today. Yeah. Well, yeah, I like the way you think. And I don't know if everybody thinks this way. In fact, I'm sure they don't. Like you're a
I'm sure they
regional.
don't too. But remember, every good idea starts with a minority of one.
Yeah, right. Right.
A lot of bad ideas start with a minority of one as well.
We'll let the viewers decide which one this is, but I think our heart is in the right place, and we're thinking creatively, and I love that after so many years. So,
Well, just
Eric,
remember the basalts were much larger than we see them today.
yes,
Yeah, you're
that's
just
the concept.
the remnants of things that were much more extensive.
I love it. I love it. Well, Eric, please hold the line. I'm going to stop the recording, and then we can talk just a little bit more with you and Catherine. But thank you so much for your time. I'm just going to stop the recording here. Thank
Okay.
you, Eric.